Imagine standing in a moonless desert thousands of years ago, long before electric lights painted our nights in artificial amber. The darkness above you is deeper than anything we know today. And the stars are everywhere. Thousands upon thousands of them scattered like grains of silver sand across the dome of night. Most of them hold their positions night after night, wheeling overhead in the same eternal patterns your ancestors learned to read like a familiar book. But there, among the steady points of light, something peculiar catches your eye, a handful of bright stars that refuse to stay where they belong. Night after night, week after week, they drift slowly through the constellations, following paths that seem to have their own mysterious logic. These are the wanderers, the planets, and they've been captivating human attention for as long as we've had eyes to see and minds to wonder. Hello and welcome to the Sleepy Astronomer. Tonight, we're embarking on a gentle journey through time and space to follow these cosmic dancers as they trace their ancient paths across our sky. We'll discover how 5 bright wandering stars became the foundation of astronomy, astrology, and our understanding of our place in the solar system. From Mercury's swift races around the sun to Saturn's slow, stately march through the zodiac, we'll learn to see the night sky through the eyes of those who first recognized that some stars were different, special, divine. If you're settling in for the first time, welcome to our quiet corner of the cosmos where science meets wonder and complex ideas become gentle bedtime stories. And if you've travelled with me before through the mysteries of space, it's wonderful to have you back among the stars. Whether you're nestled under warm blankets, settled in your favourite evening chair, or perhaps lucky enough to be somewhere you can glimpse the actual night sky, I'm delighted you're here for this particular adventure. Our journey tonight begins not with telescopes or spacecraft, but with the most ancient of all astronomical instruments, the human eye. For thousands of years, people just like you looked up at the same stars we see today and noticed something extraordinary. Among the thousands of fixed points of light, exactly 5 bright stars seem to have a will of their own, wandering through the constellations like celestial nomads, following invisible highways across the darkness. These weren't random observations by casual sky watchers. Ancient astronomers tracked these wandering stars with a patience and precision that puts many modern efforts to shame. Babylonian priests recorded their movements on clay tablets. Egyptian astronomers aligned pyramids to their rising and setting points, and Maya mathematicians calculated their cycles with accuracy that wouldn't be improved upon for centuries. Each culture gave them names that reflected their character. Swift Mercury racing ahead of the dawn, brilliant Venus shining like a jewel in the evening twilight, red Mars wandering unpredictably through the stars like a drop of blood on midnight silk. What these ancient sky watchers couldn't have known is that they were actually observing their own cosmic neighborhood, fellow worlds orbiting the same sun, each following its own elliptical dance through space. The wandering they saw was simply a matter of perspective, like watching cars on a distant highway appear to move at different speeds depending on how far away they are and which direction they're travelling. Tonight, we'll learn to see these planetary wanderers through both ancient and modern eyes. We'll discover why Mercury plays hide-and-seek with the horizon, appearing and disappearing in cycles that once baffled the greatest minds in history. We'll unravel the mystery of Venus, the morning and evening star that took centuries for astronomers to realize was actually a single world. We'll follow Mars through its strange backward dance across the sky, a puzzle so perplexing it helped spark the scientific revolution. From Jupiter's stately 12-year journey through the zodiac to Saturn's even more leisurely 29-year celestial pilgrimage, we'll explore how each planet's unique personality emerges from the simple physics of orbital mechanics. Along the way, we'll discover that the same wandering motions that once seemed like messages from the gods are actually elegant expressions of gravity, momentum, and the fundamental laws that govern everything from falling apples to spinning galaxies. There's something deeply satisfying about understanding these ancient mysteries. When you step outside on a clear night and spot Venus hanging like a diamond in the western twilight, or catch Jupiter's steady golden glow rising in the east, you're sharing an experience that connects you to every human who has ever wondered about the lights in the sky. The same photons that touch their eyes are touching yours, carrying the same light across the same vast distances of space and time. So, settle back and let your breathing slow as we prepare for this gentle tour of the solar system's most visible members. We'll move at the unhurried pace of the planets themselves, taking time to appreciate not just the science behind their motions, but the human stories of discovery, the cultural meanings different civilizations found in their wandering paths, and the quiet joy that comes from understanding our place in this grand cosmic dance. Take a deep breath, and let's begin our journey with the wanderers, past the familiar patterns of the fixed stars, through the ancient highways of the ecliptic, and into the patient rhythms that have been marking time across our sky for billions of years before humans existed, and will continue long after we're gone. Out there, in the gentle darkness between worlds, the planets continue their eternal dance, patient, predictable, and endlessly beautiful, ready to share the secrets they've been tracing across our sky since the very beginning. Picture yourself as an ancient astronomer, perhaps a Babylonian priest standing atop a ziggurat 3,000 years ago, watching the slow parade of stars wheel overhead night after night. You've memorized every constellation, learned the seasonal rhythms of the star patterns, and become so familiar with the night sky that you notice immediately when something isn't quite right. And tonight, something definitely isn't quite right. There in the constellation of the Twins, a bright star sits where no bright star should be. You check your mental map of the heavens, consulting memories passed down through generations of skywatchers, and you're certain this newcomer doesn't belong here. Yet there it shines, steady and bright, looking for all the world like it has every right to be where it is. Over the coming nights you watch in fascination as this mysterious visitor begins to drift, slowly but unmistakably against the backdrop of the familiar star patterns. It's moving eastward through the constellation, following an invisible path that seems to obey laws you don't yet understand. What you've discovered is one of the wanderers, the planets, and you've just joined a select group of humans who have noticed that the universe is far more dynamic and mysterious than it first appears. The ancient Greeks had a wonderfully descriptive word for these celestial nomads, planets meaning wanderers. It's a term that captures perfectly the sense of these bright stars that refuse to stay put, drifting through the constellations like cosmic travelers, following secret highways across the darkness. Unlike the fixed stars that maintain their relative positions night after night, these 5 special lights seem to have minds of their own, each following its own schedule and tracing its own path through what the Greeks called the zodiac, the strip of sky where all the planetary action takes place. You might wonder why ancient astronomers were so certain that most stars were fixed, while others were wandering. The answer lies in the remarkable human ability to notice patterns, and more importantly, to spot when something breaks those patterns. Ancient skywatchers developed memories that put our GPS-dependent modern minds to shame. They knew every star, every constellation, every subtle seasonal shift in the night sky's appearance. So when a bright star appeared, where none should be, or when a familiar star began drifting slowly through the background of other stars, it stood out like a moving light in an otherwise static photograph. The 5 classical planets, Mercury, Venus, Mars, Jupiter and Saturn, are all bright enough to be easily visible to the naked eye, which is why they were known to every ancient civilization that bothered to look up regularly. But their brightness isn't constant, and that's part of what made them so fascinating and mysterious to early astronomers. Sometimes they blaze forth as the brightest objects in the night sky, rivaling even Venus at her most spectacular. Other times they fade to barely perceptible dots, testing the limits of what the human eye can detect on a dark night. This variation in brightness follows a pattern, though it took thousands of years for humans to figure out what that pattern meant. When a planet appears in the part of the sky opposite the Sun, what astronomers call opposition, it's essentially at its closest approach to Earth, which makes it appear larger and brighter. Think of it as a cosmic version of approaching headlights on a dark highway. When the planet is on the far side of the Sun, from our perspective, at superior conjunction, it's at its most distant, appearing smaller and dimmer, sometimes disappearing entirely in the Sun's glare. The dance becomes even more complex when you consider that each planet moves at its own pace. Mercury, closest to the Sun, races around its orbit in just 88 Earth days, which means it's constantly appearing and disappearing from our view as it alternately catches up with the Sun and falls behind it. Saturn, on the other hand, takes nearly 30 years to complete one orbit, which means it moves so slowly against the background stars that ancient astronomers could watch it for their entire lives and still not see it complete one full journey through the zodiac. Venus deserves special mention as the showstopper of the planetary family. When conditions are right, Venus can shine so brilliantly that it casts shadows on the ground, shadows you can actually see on a dark night if you know where to look. It's bright enough to be visible even in broad daylight if you know exactly where to look for it, though finding it requires either exceptional eyesight or a good pair of binoculars. The Romans called it both Lucifer, the light bearer, when it appeared as the morning star, and Vesper, when it graced the evening sky. For centuries, many cultures thought these were 2 separate celestial objects, which just goes to show how mysterious these wandering lights could be. Mars earned its reputation as the Red Wanderer, and that distinctive ruddy colour made it stand out even among the other bright planets. Unlike the steady silver-white light of Jupiter or the brilliant diamond sparkle of Venus, Mars glows with an unmistakable orange-red tint that reminded ancient observers of blood, fire and warfare. This coloration, combined with its somewhat unpredictable behaviour, made Mars the most ominous of the classical planets in many mythological systems. Jupiter, the king of planets in terms of brightness and steady behaviour, provided ancient astronomers with a reliable celestial timekeeper. Its 12-year orbital period meant that Jupiter spent roughly 1 year in each zodiacal constellation, making it a cosmic calendar that helped early civilizations track longer periods of time. If you were born when Jupiter was in a particular constellation, you could expect it to return to that same position on your 12th birthday, your 24th, your 36th, and so on. Saturn, the most distant of the naked eye planets, barely qualifies as a wanderer from the perspective of a human lifetime. Its 29.5-year orbit means that it moves so slowly against the stars that you need considerable patience to detect its motion. Ancient astronomers who began tracking Saturn as young adults might not live to see it complete even one full circuit of the zodiac. This sluggish behaviour, combined with its somewhat dim appearance compared to the other bright planets, gave Saturn a reputation for being associated with old age, limitation, and the slow grind of time itself. What makes these 5 planets so special from an observational standpoint isn't just their wandering behaviour, it's their combination of brightness and visibility. The solar system actually contains 3 more planets: Uranus, Neptune, and depending on your astronomical politics, Pluto. But these were invisible to ancient observers. Uranus, discovered by William Herschel in 1781, is just barely bright enough to be visible to the naked eye under perfect conditions, but it's so faint that it looks like just another dim star unless you're specifically looking for planetary motion. Neptune and Pluto require telescopes even to be seen, let alone tracked as they move through their orbits. The classical planets all follow the same basic highway across our sky, the ecliptic, which is simply the apparent path the Sun takes through the constellations over the course of a year. This ecliptic represents the plane of our solar system, and all the planets stay relatively close to this invisible line as they wander through the stars. The zodiacal constellations, Aries, Taurus, Gemini, and the rest, are simply the star patterns that happen to lie along this celestial highway. When ancient astrologers spoke of planets being in various zodiacal signs, they were describing which constellation provided the backdrop for each planet's current position along the ecliptic. Understanding this basic geometry helps explain why planets sometimes appear to move backward or retrograde against the background stars, one of the most puzzling aspects of planetary motion for ancient astronomers. Imagine you're driving on a highway and you begin to overtake a slower car. From your perspective, that slower car appears to move backward relative to the distant landscape, even though both of you are actually moving forward. The same thing happens when Earth, travelling in its inner, faster orbit, overtakes one of the outer planets. Mars, Jupiter, and Saturn all show this retrograde motion when Earth passes them, creating loops and zigzags in their paths that mystified astronomers for centuries. The brightness variations of planets also follow predictable patterns once you understand the geometry involved. When Mars is at opposition, directly opposite the Sun in Earth's sky, it's not only at its closest approach to us, but we're also seeing its fully illuminated face, just like a full moon. This combination makes Mars appear dramatically brighter than when it's at conjunction on the far side of the Sun, where it's both distant and showing us only its shadowed side. Mercury and Venus, the inner planets, show a different pattern because they're always relatively close to the Sun from our perspective. They go through phases just like the Moon, appearing as crescents when they're closest to us, and as nearly full disks when they're farthest away. This means their brightness depends on a complex interplay between how close they are and how much of their illuminated face we can see. The colours of the planets provide another layer of identification for skywatchers both ancient and modern. Mercury appears as a faint, slightly yellowish star that rarely stays visible for long. Venus blazes forth with an intense white light that has a slight blue tint when viewed through binoculars or a telescope. Mars glows with its famous ruddy orange colour, caused by iron oxide, essentially rust, on its surface. Jupiter appears as a steady, creamy white light, while Saturn shows a distinct golden or yellowish hue that helped ancient observers distinguish it from ordinary stars. These colour differences arise from various factors: the temperature and composition of planetary atmospheres, the materials that make up planetary surfaces, and the way different substances reflect sunlight. Venus appears so bright and white because its thick atmosphere of sulfuric acid clouds reflects nearly all the sunlight that hits it, acting like a cosmic mirror. Mars looks red because its surface is literally covered in rusty dust. Jupiter's complex atmosphere creates its creamy appearance, while Saturn's composition gives it that distinctive golden glow. For modern planet watchers, these same principles apply. You don't need expensive equipment to become a planetary observer. The same eyes that served ancient astronomers can still show you the wandering stars in all their glory. A simple pair of binoculars will reveal the phases of Venus, the 4 largest moons of Jupiter, and the rings of Saturn, though you'll need to know what to look for and when to look. The key to successful planet watching is the same today as it was thousands of years ago: patience, regular observation, and careful attention to detail. Planets don't announce themselves with flashing signs or cosmic fanfare. They reveal their nature through subtle clues that accumulate over time. A bright star that seems to be in the wrong place, or a familiar constellation that suddenly has one more bright member than you remember. These are the gentle signals that invite you to join the ancient fellowship of skywatchers, who first noticed that some stars have stories of their own to tell. As we continue our journey through the solar system's most visible members, we'll discover how each planet earned its unique personality through the patient observations of generations of astronomers. From Mercury's swift appearances and disappearances to Saturn's stately progress through the zodiac, each world has its own rhythm, its own character, its own way of catching the attention of those who take the time to watch and wonder. The wandering stars are still out there, following the same paths they've traced for billions of years, waiting for curious eyes to spot them among the familiar patterns of the fixed stars. They're patient teachers, these planets, willing to share their secrets with anyone who takes the time to notice their gentle motion against the stellar backdrop. All you need is a clear sky, a little patience, and the same sense of wonder that first led ancient skywatchers to notice that some stars refuse to stay where they're supposed to be. Have you ever had a friend who's perpetually late to everything except when they're inexplicably early? Mercury is a bit like that, utterly unpredictable in its timing, yet somehow following a schedule so precise you could set your cosmic watch by it, if only you knew the secret. This smallest planet in our solar system has been playing cosmic hide-and-seek with sky watchers for thousands of years, popping up briefly in the twilight before vanishing again like a shy performer who only appears for the briefest of encores. Standing outside on a clear evening, scanning the western horizon about half an hour after sunset, you might catch a glimpse of Mercury hanging there like a modest golden star. But blink, and you might miss it. Not because it actually disappears in the moment you look away, but because Mercury's window of visibility is so narrow, so delicate, that even a few clouds or a slightly hazy evening can erase it from view entirely. It's the astronomical equivalent of trying to spot a single candle flame from across a brightly lit stadium. Mercury earned its reputation as the messenger of the gods, not just because of its swift orbital motion, but because of this maddening habit of delivering brief, cryptic appearances before racing off to who knows where. The ancient Greeks were so puzzled by Mercury's behaviour that they actually thought they were seeing 2 different objects, one that appeared in the morning before dawn, which they called Hermes, and another that showed up in the evening after sunset, which they named Apollo. You can hardly blame them for this confusion. When you see a bright star in the morning for several days, then nothing for weeks, followed by a completely different bright star appearing in the evening, the logical conclusion is that you're dealing with 2 separate celestial visitors. It wasn't until much later that Greek astronomers realized these morning and evening appearances were actually the same wandering star, caught at different phases of its eternal dance around the sun. Imagine their delight and perhaps slight embarrassment when they figured out they'd been tracking one very clever planet that was simply taking turns playing morning star and evening star, like a cosmic actor switching between two different roles in the same play. The secret to Mercury's mysterious behavior lies in its intimate relationship with the Sun. Mercury orbits so close to our star that it completes its entire journey, what we call a mercurial year, in just 88 Earth days. To put this in perspective that might make you feel either very patient or very rushed, depending on your temperament, Mercury experiences 4 complete seasons, while we're still deciding whether spring has truly arrived. By the time you've grown tired of hearing about March Madness, Mercury has already celebrated 4 new years and is well into its 5th orbit. This breakneck orbital pace means Mercury never strays very far from the Sun as seen from our earthly perspective. It's like having a friend who's tethered to someone who carries an enormous flashlight. You can only see them clearly when they manage to step far enough away from the glare, and even then, only briefly before they're pulled back into the overwhelming brightness. The key moments for Mercury spotting happen during what astronomers call greatest elongation, those special times when Mercury appears farthest from the Sun in our sky. Picture Mercury as a dog on a cosmic leash, and greatest elongation is when it reaches the full extent of that leash, giving us the best possible viewing angle. These elongations occur roughly every 116 days, which sounds frequent until you realize that many of them happen when Mercury is positioned where we can't actually see it, either because it's elongating on the wrong side of the Sun, or because the geometry of the orbits places it below our horizon during the brief window when it might be visible. But here's where Mercury gets delightfully complicated, like a cosmic puzzle designed by someone with a mischievous sense of humour. Not all elongations are created equal. Sometimes Mercury manages to appear about 28 degrees from the Sun, roughly the width of your fist held at arm's length, while other times it only reaches about 18 degrees, which is more like the width of 2 fingers. This variation happens because Mercury's orbit isn't a perfect circle, but rather a slightly stretched ellipse, like a circle that someone sat on very gently. When Mercury reaches greatest elongation at the far end of its elliptical orbit, it can achieve that comfortable 28-degree separation, giving patient observers a reasonable window of opportunity. But when greatest elongation occurs at the near end of Mercury's orbit, the planet appears smaller, dimmer, and closer to the Sun's glare, making it a much more challenging target for skywatchers. It's as if Mercury occasionally decides to make itself easier to spot, then changes its mind and opts for maximum stealth mode instead. The seasonal timing of these appearances adds yet another layer to Mercury's cosmic choreography. If you live in the northern hemisphere, spring evenings offer the most favourable conditions for catching Mercury in the western twilight. During these times, the angle of the ecliptic, that invisible highway where all the planets travel, creates perfect geometry for evening Mercury hunting. The planet sets well after the Sun, hanging in the darkening sky like a golden punctuation mark at the end of the day's cosmic sentence. Autumn mornings, on the other hand, provide the best opportunities to catch Mercury in its morning star roll, rising ahead of the Sun in the eastern sky. There's something particularly magical about spotting Mercury in the pre-dawn darkness, when the world is still quiet and the planet appears like an advance scout announcing the coming sunrise. Picture yourself on one of these perfect Mercury mornings, perhaps in late September or early October. You've set your alarm for that peculiar pre-dawn hour when the world exists in a state of gentle suspension between night and day. The eastern horizon shows just the faintest blush of light, and the stars are beginning their slow fade into the approaching daylight. As you scan the eastern sky, there it is, Mercury, hanging above the horizon like a modest golden star, neither as brilliant as Venus nor as dramatic as Mars, but unmistakably there, unmistakably moving on its own mysterious schedule. Mercury's colour is subtly distinctive once you know what to look for. It doesn't blaze with the diamond-white intensity of Venus or glow with the ruddy fire of Mars. Instead, Mercury appears as a gentle, slightly yellowish star with a warm golden tint that becomes more noticeable when you view it through binoculars. This coloration comes from Mercury's essentially airless, rocky surface, reflecting sunlight without the atmospheric filtering that gives other planets their more dramatic hues. Through even a modest pair of binoculars, Mercury often reveals one of its most fascinating secrets. It shows phases, just like the Moon. Depending on Mercury's position in its orbit relative to Earth and the Sun, you might catch it as a tiny crescent, a half disk, or approaching full phase. These phases were completely invisible to ancient observers, adding to Mercury's mystery and making it seem even more like a magical star that followed rules no earthly object could match. The ancient Babylonians, those master sky watchers of the ancient world, called Mercury Nabu, after their god of writing and wisdom. This choice of deity wasn't arbitrary. It reflected their understanding that Mercury was a messenger, appearing regularly to deliver what seemed like coded communications from the heavens before disappearing again into the solar glare. They tracked Mercury's appearances with remarkable precision, developing mathematical techniques that could predict its elongations months or even years in advance. Imagine their satisfaction at cracking Mercury's code, learning to anticipate its appearances like reading the schedule of a very punctual but very mysterious celestial postal service. Egyptian astronomers associated Mercury with Thoth, the ibis-headed god of wisdom, writing, and measurement. They recognized that Mercury's appearances followed patterns linked to the seasons and the agricultural calendar, making it a useful timekeeper for those initiated into its mysteries. The fact that Mercury was visible only briefly, and only to those who knew exactly when and where to look, enhanced its reputation as a keeper of secret knowledge, a celestial teacher who shared wisdom only with the most dedicated students. The Maya, those incredible astronomers of Mesoamerica, wove Mercury into their intricate calendar systems with characteristic precision. They understood that Mercury's cycle from one morning appearance to the next, similar morning appearance, averaged about 116 days, and they used this knowledge to create long-term predictions that helped synchronize their civil and religious calendars. Maya astronomers were particularly fascinated by the mathematical relationships between different planetary cycles, and Mercury's rapid period made it an essential component in their calculations of cosmic harmony. In ancient China, Mercury was known as the water star, one of 5 celestial wanderers associated with the fundamental elements of their cosmological system. Chinese astronomers noticed that Mercury's quick appearances and disappearances made it an ideal celestial timekeeper for shorter periods, while its association with water connected it to concepts of flow, change, and adaptation. They developed sophisticated techniques for predicting Mercury's favorable viewing periods, information that was closely guarded as part of the Imperial Astronomical Service. During the Islamic Golden Age, astronomers in places like Baghdad and Cordoba made remarkable advances in understanding Mercury's behavior. They refined the mathematical models inherited from Greek and Indian astronomers, developing new techniques for calculating Mercury's position with extraordinary accuracy. The Persian astronomer al-Biruni, working in the 11th century, calculated Mercury's orbital period to within minutes of the modern value, a remarkable achievement using only naked-eye observations and mathematical ingenuity. These Islamic astronomers also grappled with one of Mercury's most puzzling aspects. Its orbit isn't quite regular. They noticed tiny discrepancies in Mercury's predicted positions, variations that wouldn't be fully explained until the 20th century, when Einstein's theory of general relativity revealed that Mercury's orbit actually precesses slightly due to the curvature of spacetime near the Sun. But even without understanding the cause, medieval astronomers recognized that Mercury was keeping secrets that challenged their best theories. When Galileo first turned his telescope toward Mercury in the early 1600s, he discovered that this elusive planet showed phases, just like Venus and the Moon. This observation provided strong support for the Copernican model of the solar system, demonstrating that Mercury orbited the Sun rather than Earth. However, Mercury's small size and proximity to the Sun made it one of the most challenging objects for early telescopic observers. Even today, with much better instruments, Mercury remains a difficult target for amateur astronomers, visible for only brief periods and requiring precise timing to catch it at its best. Modern Mercury hunters have advantages that ancient astronomers could only dream of, yet the fundamental challenge remains the same. Smartphone apps can pinpoint Mercury's exact position in the sky, but you still need clear weather, an unobstructed horizon, and the patience to look at exactly the right time. There's something deeply satisfying about succeeding at this ancient challenge, about catching that brief golden glint in the twilight, and knowing you've spotted the same elusive wanderer that has been fascinating humans for thousands of years. The best advice for modern Mercury watching is delightfully simple. Be patient, be persistent, and remember that Mercury rewards those who pay attention to its schedule rather than expecting it to appear on demand. Check an astronomy app or website to find out when Mercury's next favourable elongation occurs. Mark your calendar, and then actually go outside during the predicted viewing window. Like any shy performer, Mercury appreciates an attentive audience, and once you've successfully spotted it during one elongation, you'll find it much easier to catch during future appearances. There's also something poetic about the fact that Mercury, the smallest planet in our solar system, presents one of the greatest challenges for naked-eye observers. It's a reminder that in astronomy, as in life, the most rewarding discoveries often require patience, preparation, and a willingness to step outside your comfortable routine. Mercury might be playing hard to get, but it's been following the same predictable schedule for billions of years, appearing precisely when orbital mechanics dictate it should appear, disappearing exactly when its cosmic choreography demands. So the next time you hear about a favourable Mercury viewing opportunity, consider stepping outside during that narrow window of possibility. Look for that modest golden star hanging in the twilight, and remember that you're participating in an ancient human tradition that stretches back to the very beginnings of astronomy. Mercury might be swift and elusive, but it's also reliable and patient, willing to share its brief appearances with anyone who takes the time to learn its schedule and respect its cosmic constraints. Have you ever been completely convinced you knew someone, only to discover later that you'd actually been looking at their identical twin all along? For thousands of years, this is exactly what happened with Venus, humanity's most spectacular case of mistaken celestial identity. Ancient sky watchers were absolutely certain they were tracking two entirely different objects, a brilliant morning star that heralded the dawn and an equally dazzling evening star that graced the twilight hours. The idea that these might be the same wandering light, playing an elaborate cosmic game of dress-up, seemed as unlikely as discovering that the sun and moon were secretly the same object taking turns in the sky. Venus, you see, has a flair for the dramatic that puts every other planet to shame. When it decides to make an appearance, it doesn't mess around with subtle hints or modest twinkles. Venus blazes forth with such brilliant intensity that it can actually cast shadows on the ground during a dark night. Real, visible shadows that you can see if you know where to look and have reasonably good eyesight. It's the third brightest object in our sky after the sun and moon, which means that on a clear night, Venus can be so spectacular that people sometimes mistake it for an airplane, a UFO, or even the International Space Station. This extraordinary brightness comes from a rather unfortunate cosmic circumstance that makes Venus simultaneously beautiful from a distance and utterly hellish up close. Venus is wrapped in a thick blanket of clouds made primarily of sulfuric acid, which sounds about as pleasant as it is. But these same clouds that create a surface environment hot enough to melt lead also act like a cosmic mirror, reflecting nearly all of the sunlight that strikes them back into space. The result is a planet that gleams like a polished pearl against the darkness of space. The mystery of Venus's dual identity persisted for centuries because of the planet's peculiar orbital dance with Earth and the Sun. Unlike Mercury, which never strays very far from the Sun in our sky, Venus can appear quite distant from our star, as much as 47 degrees away, which is nearly the width of your outstretched hand at arm's length. But Venus never appears in the middle of the night sky, opposite the Sun like Mars or Jupiter sometimes do. Instead, it confines its performances to those magical hours around sunrise and sunset, when the sky is painted in soft colours and the boundary between day and night becomes beautifully blurred. When Venus appears as the morning star, it rises before the sun in the eastern sky, hanging there like a cosmic lighthouse guiding the dawn toward the horizon. These morning appearances can be absolutely breathtaking, especially during the most favourable periods when Venus rises several hours before sunrise. Picture yourself stepping outside on a clear morning in late autumn, perhaps around 5 a.m. when the world is still wrapped in darkness. As you look toward the east, there's Venus blazing away above the horizon, so bright it seems almost artificial, like someone hung an enormously powerful LED light in the sky. The ancient Greeks called this morning apparition Phosphoros, meaning light-bringer or dawn-bearer. The name captures perfectly the sense of anticipation that comes with seeing Venus in the pre-dawn sky. It's not just a beautiful sight, but a herald announcing that sunrise is on its way. There's something deeply satisfying about being up early enough to witness this cosmic curtain raiser, this preview of the day to come. But then, after weeks or months of morning performances, something curious happens. Venus gradually moves closer and closer to the sun in our sky, rising later and later each morning, until finally it disappears entirely into the solar glare. For ancient observers who didn't understand the underlying orbital mechanics, Venus had simply vanished, perhaps returning to whatever celestial realm it called home when not gracing the morning sky. The disappearance, however, is only temporary. After a few weeks of absence, a period astronomers call superior conjunction, when Venus is on the far side of the Sun from Earth, Venus makes a stunning comeback. But now it appears in the evening sky, setting after the sun in the west, taking on its role as the evening star. This evening apparition can be even more spectacular than the morning show, because Venus often appears highest in the sky during comfortable evening hours when more people are likely to be outside to appreciate its beauty. The Greeks called this evening incarnation Hesperos, the evening star, and they created an entirely separate mythology around it. To them, Phosphoros and Hesperos were as different as, well, day and night. One belonged to the realm of dawn and new beginnings, while the other presided over twilight and the approaching darkness. The idea that they might be the same celestial object would have struck ancient observers as absurd, like suggesting that your morning coffee and your evening tea were actually the same beverage in disguise. The revelation that Phosphoros and Hesperos were actually the same wandering star represents one of the great aha moments in the history of astronomy. The credit for this discovery is usually given to Pythagoras in the 6th century BCE, though like many ancient discoveries, the truth probably emerged gradually through the observations of multiple astronomers over time. Imagine the mixture of surprise, delight, and perhaps slight embarrassment when Greek astronomers realized they'd been tracking one very talented planet that was simply taking turns playing two different roles. Understanding Venus's behavior requires grasping the geometry of its orbit around the Sun. Venus travels in a nearly circular path that lies between Earth's orbit and the Sun, which means it's what astronomers call an inferior planet. This orbital arrangement creates the pattern of appearances that so puzzled ancient observers. When Venus is on the far side of the Sun from Earth, it appears as the morning star rising before dawn. As Venus continues in its orbit, it gradually appears closer and closer to the Sun in our sky until it disappears into the solar glare. Then, as Venus swings around to our side of the Sun, it reappears as the evening star, setting after sunset. This complete cycle from one morning appearance to the next takes approximately 584 days, about 19 months, which is why Venus's appearances have such a long, stately rhythm. You might catch Venus as a brilliant morning star, then not see it again in the morning sky for more than a year and a half. The Maya astronomers of Mesoamerica understood this cycle with remarkable precision, incorporating Venus's 584-day period into their complex calendar systems. They recognized that 5 Venus cycles almost exactly equal 8 Earth years, a mathematical relationship they found so significant that they used it to synchronize their civil and religious calendars. Maya astronomers could predict Venus's appearances decades in advance, and they associated different phases of the Venus cycle with various agricultural and ceremonial activities. In ancient Mesopotamia, Venus was identified with Ishtar, the powerful goddess of love and war. This seemingly contradictory association, love and war, actually makes perfect sense when you consider Venus's behavior in the sky. As the morning star, Venus was seen as a warrior goddess, rising before dawn like a celestial army preparing for battle with the approaching sun. As the evening star, Venus became the goddess of love and beauty, gracing the romantic hours of twilight with her gentle presence. The Romans inherited this dual nature but simplified the mythology, associating Venus with their goddess of love and beauty. The name Venus comes from this Roman tradition, though they also sometimes call the morning star Lucifer, meaning light bearer, the same concept as the Greek Phosphoros. This Latin name for the morning star would later take on quite different connotations in Christian theology, but in its original astronomical context, Lucifer was simply a poetic description of Venus's role as the bringer of dawn. One of the most remarkable things about Venus is just how bright it can become during favourable appearances. At its best, Venus reaches a magnitude of about -4.7, which in astronomical terms is incredibly brilliant. To put this in perspective, the brightest star in our night sky, Sirius, has a magnitude of -1.4, which means Venus can be more than 16 times brighter than the most brilliant star. This extraordinary brightness explains why Venus has been visible and celebrated by every human culture that bothered to pay attention to the sky. The brightness of Venus also varies considerably during its 584-day cycle, and understanding this variation helps explain some of the mystery that surrounded the planet for so long. When Venus appears as a tiny dot on the far side of the Sun, it's showing us its fully illuminated face, but it's also at its most distant from Earth. As Venus swings closer to us in its orbit, it appears larger, but also shows us less of its illuminated side. It goes through phases just like the Moon. The combination of changing distance and changing phase creates a complex pattern of brightness variation that reaches its maximum when Venus is about 25% illuminated and relatively close to Earth. Galileo's telescopic observations of Venus in the early 1600s provided some of the strongest evidence for the Copernican model of the solar system. When Galileo turned his telescope toward Venus, he discovered that it showed the complete range of phases, from a thin crescent when it was close to Earth to a full disk when it was on the far side of the Sun. These observations were impossible to explain in the old Earth-centered model, but made perfect sense if Venus orbited the Sun as Copernicus had proposed. The phases of Venus are actually visible through modest binoculars or a small telescope, making it one of the most accessible planetary observations for amateur astronomers. When Venus is at its brightest and closest to Earth, it appears as a beautiful, thick crescent that looks remarkably like a tiny version of the crescent moon. Through binoculars, this crescent phase is quite unmistakable, and spotting it for the first time can be a genuinely thrilling experience. You're seeing direct evidence that Venus is a world orbiting the Sun, not just a mysterious light in the sky. Modern Venus watchers have the advantage of understanding the planet's cycle, which makes it much easier to appreciate both its morning and evening performances. When Venus is well placed as an evening star, it becomes a focal point for evening walks and outdoor gatherings. There's something magical about pointing out Venus to children or friends who might not have noticed it before, that moment when they spot it for the first time and realize just how bright and beautiful it really is. Venus also has the distinction of being visible in broad daylight, though finding it requires either exceptional eyesight or optical aid and precise knowledge of where to look. On those rare occasions when Venus is at its brightest and the atmospheric conditions are just right, you can sometimes spot it as a tiny white dot in the clear blue sky, usually best seen during the late afternoon when Venus is high above the horizon. It's a surreal experience, seeing a planet in the daytime sky, and it helps explain why Venus has sometimes been mistaken for more exotic phenomena. The orbital mechanics that create Venus's morning and evening star cycle also mean that Venus never appears in the middle of the night. While Mars, Jupiter and Saturn can sometimes shine overhead at midnight, Venus is always confined to those liminal hours around dawn and dusk. This limitation is actually part of Venus's charm. It belongs to the twilight hours, those magical times when the sky displays its most beautiful colours and the boundary between day and night becomes soft and ambiguous. Throughout history, Venus has inspired more poetry, mythology and romantic associations than any other planet, and it's easy to understand why. Whether rising before dawn like a cosmic jewel announcing the coming day, or setting after dusk like a celestial lantern illuminating the evening, Venus brings a touch of beauty and mystery to those quiet hours when the world feels most peaceful and contemplative. The next time you're outside during either dawn or dusk and you spot that unmistakably brilliant star hanging in the coloured sky, take a moment to appreciate the long journey of human understanding that connects you to ancient sky watchers who saw the same beautiful sight. They might have thought they were seeing two different objects, but they recognized the same sense of wonder and beauty that Venus continues to inspire today. In a way, their mistake was perfectly understandable. Venus is so spectacular in both its morning and evening roles that it really does seem like it could be two different celestial performers taking turns on the cosmic stage. Have you ever had one of those dreams where you're walking in a perfectly straight line, only to suddenly realize you're somehow moving backward without having turned around? Mars has been pulling this exact trick on sky watchers for thousands of years, and it's the kind of celestial sleight of hand that can make even the most dedicated astronomer wonder if they need to have their eyes checked. For ancient observers who expected the wandering stars to at least follow some basic rules of polite cosmic behaviour, Mars was that one guest who showed up to the celestial party and proceeded to dance backward across the floor while everyone else waltzed in the proper direction. The first thing you notice about Mars, even with casual stargazing, is its colour. While other bright planets might masquerade as ordinary stars until you pay close attention, Mars announces itself with an unmistakable warm reddish glow that stand out like an ember floating in the darkness. It's not the deep crimson that some dramatic photographs suggest, more like the colour of a desert sunset or perhaps a glass of rosé wine held up to candlelight. This distinctive hue comes from iron oxide coating Mars's surface, which is a fancy way of saying the entire planet is covered in rust dust, making it the solar system's largest example of what happens when you leave iron outside for a very long time. But Mars doesn't just stand there glowing red and minding its own business. Oh no, that would be far too simple for a planet with such a reputation for mischief. Mars has the most dramatic personality changes of any naked-eye planet, transforming from a modest, barely noticeable point of light to a blazing beacon that can outshine every star in the sky, then fading back to virtual invisibility as if it's playing an eternal game of cosmic peekaboo. During opposition, those special times when Mars appears opposite the Sun in our sky, the red planet can become genuinely spectacular. Picture stepping outside on a clear autumn evening when Mars is at its best, perhaps around 10 p.m. when the sky has settled into full darkness. There, hanging high overhead, like a celestial traffic light stuck on orange, is Mars burning with such steady intensity that it seems almost artificial. Unlike the twinkling of distant stars, Mars shines with a steady glow that immediately identifies it as something much closer, much more substantial than those distant suns scattered across the galaxy. The brightness of Mars during these favourable oppositions can be truly remarkable, bright enough to read by if you're patient and have good eyesight and perhaps a book with unusually large print. More practically, it's bright enough to cast actual shadows during a dark night, though you need to be far from city lights, and allow your eyes plenty of time to adjust to really notice this subtle effect. There's something deeply satisfying about standing in the darkness with Mars overhead, knowing that the faint shadow at your feet is being cast by sunlight, reflecting off the rusty deserts of another world. But then, as Earth continues in its orbit and gradually leaves Mars behind, something fascinating happens. Mars begins to fade, slowly but noticeably, shrinking from a brilliant beacon back toward ordinary starhood. This isn't the gentle dimming of a light on a rheostat. It's more like watching someone gradually walk away from you across an enormous field, becoming smaller and less distinct with each passing week. Eventually, Mars fades so much that you need genuinely dark skies and good observing conditions even to spot it, a dim reddish dot that bears little resemblance to the blazing wanderer that commanded attention just months earlier. The ancient Greeks must have found this transformation deeply puzzling. Imagine tracking Mars night after night, watching it maintain a steady eastward progress through the constellations like a well-behaved celestial citizen, when suddenly it does something that challenges everything you think you understand about how wandering stars should behave. First, Mars slows down in its eastward motion, then it stops entirely, hovering in the same spot among the background stars for several nights, like a cosmic hitchhiker waiting for a ride. Then comes the truly bewildering part. Mars starts moving backward, retracing its path through the constellation in the wrong direction entirely. For several weeks, this red wanderer executes a slow-motion backward dance against the star patterns, creating a graceful loop in its path that seems to defy every assumption about planetary motion. Eventually, Mars stops its backward journey, pauses again as if collecting its thoughts, then resumes its original eastward progress as if nothing unusual had happened. This retrograde motion, as astronomers came to call it, was Mars's signature move, and it happened with predictable regularity every time Earth lapped Mars in the cosmic racetrack of the solar system. But understanding the cause of this apparent backward motion required a fundamental shift in how humans thought about the structure of the solar system, a shift that wouldn't come for more than 1,000 years after the behavior was first carefully documented. The Greeks, working within their Earth-centered model of the universe, developed increasingly elaborate explanations for Mars's retrograde loops. The astronomer Ptolemy created a system of epicycles, essentially circles riding on circles, that could mathematically account for Mars's backward dance. But the resulting model was so complex it resembled a cosmic Rube Goldberg machine. It worked in the sense that it could predict when Mars would start and stop its retrograde motion, but it felt more like a mathematical band-aid than a true understanding of what was actually happening. The real explanation, of course, is beautifully simple once you understand that Earth and Mars are both orbiting the Sun at different speeds and distances. Earth, travelling in the inner lane of the solar system's highway, occasionally overtakes Mars like a faster car passing a slower one on the freeway. During the passing manoeuvre, Mars appears to move backward relative to the distant background of stars. Just like that, slower car seems to drift backward relative to the far mountains as you overtake it. Once Earth completes the pass and moves ahead in its orbit, Mars resumes its normal eastward motion relative to the stars. This explanation seems obvious to us now, but it required nothing less than a complete revolution in human thinking about our place in the universe. The idea that Earth was racing around the Sun, carrying us all along as passengers on a cosmic journey, was so contrary to everyday experience that it took centuries for the concept to gain widespread acceptance, even among professional astronomers. Mars played a crucial role in this astronomical revolution. When Tycho Brahe, that meticulous Danish astronomer, spent decades making incredibly precise measurements of Mars's position, he created a dataset that would prove crucial for understanding planetary motion. Johannes Kepler, working with Tycho's Mars observations, discovered that planets orbit the Sun in ellipses rather than perfect circles, a finding that finally made the mathematics of planetary motion simple and elegant rather than complex and cumbersome. There's something poetic about the fact that Mars, the planet that most confused ancient astronomers with its apparently chaotic behavior, became the key to understanding the underlying order of the solar system. Mars's retrograde loops, which seemed like evidence of cosmic chaos, were actually perfect expressions of the gravitational clockwork that governs planetary motion. The backward dance that mystified observers for millennia was simply a natural consequence of orbital mechanics viewed from a moving platform. For ancient cultures, Mars's unpredictable behavior and blood-red color made it a natural choice for association with war, conflict, and divine displeasure. The Babylonians called it Nergal, after their god of war and pestilence, while the Greeks named it Ares and the Romans Mars, both war deities known for their unpredictable and often destructive nature. In many mythological systems, Mars's retrograde motion was interpreted as the god changing his mind about some cosmic battle plan, or perhaps retreating temporarily before launching a new offensive. Chinese astronomers called Mars the Fire Star, and developed elaborate systems of omens based on its position and brightness. When Mars appeared in certain constellations, or when it performed its retrograde dance near particular star groups, Chinese court astronomers would issue warnings about potential rebellions, natural disasters, or threats to the imperial dynasty. The planet's variable brightness added another layer of interpretation. A bright Mars was generally considered more ominous than a dim one, as if the war god's power waxed and waned with the planet's visibility. The Maya included Mars in their astronomical calculations, though its irregular cycle made it more challenging to incorporate into their calendar systems than the more predictable Venus or Jupiter. Mars's synodic period, the time from one opposition to the next, averages about 780 days, or roughly 26 months, which doesn't form neat mathematical relationships with the solar year or other planetary cycles. This irregularity probably added to Mars's reputation as an unpredictable and potentially troublesome celestial influence. Modern Mars watchers have the enormous advantage of understanding the planet's behavior, which transforms its retrograde motion from a mysterious aberration into an elegant demonstration of orbital mechanics. When you watch Mars execute one of its backward loops, you're not seeing evidence of cosmic chaos. You're witnessing a beautiful geometric dance between two worlds, orbiting the same star at different speeds. There's also something deeply satisfying about being able to predict Mars's behavior with precision. Astronomy apps and websites can tell you exactly when Mars will reach opposition, how bright it will become, and when it will begin and end its retrograde motion. But even with this predictive power, there's still magic in stepping outside during a favourable Mars opposition and seeing that unmistakable red glow burning steadily overhead. The best Mars oppositions, those perihelic events when Mars comes particularly close to Earth, occur roughly every 15 to 17 years, and they're genuine astronomical events worth marking on your calendar. The opposition of 2003 was particularly memorable because Mars came closer to Earth than it had in nearly 60,000 years, appearing so bright and distinctly red that even people who never usually notice celestial objects stopped to comment on the unusual star in the sky. Mars also offers patient observers the chance to watch its brightness change over the course of months or even years. Unlike Venus, which can hide behind the sun's glare for weeks at a time, Mars remains visible for much longer periods, allowing you to track its gradual brightening as opposition approaches and its slow fading as Earth pulls ahead in the orbital race. There's something almost companionable about having Mars visible in the evening sky for months at a time. Unlike Mercury, which plays hard to get, or Venus, which dominates twilight but then disappears, Mars settles into the night sky like a patient friend, hanging there night after night in slightly different positions, slowly brightening or dimming as the orbital geometry changes. The red wanderer continues its ancient dance across our sky, still executing the same retrograde loops that mystified our ancestors, still varying in brightness according to the same gravitational rhythms that have governed its motion since the solar system formed. The only difference is that now we understand the cosmic choreography behind Mars's performance, which somehow makes it even more beautiful rather than less mysterious. We're no longer watching chaos, we're watching physics, rendered in starlight against the darkness of space. If the planets formed a royal court, Jupiter would undoubtedly be the benevolent king, steady, reliable, and possessed of a natural dignity that commands respect without demanding attention, while Mercury races around like an over-enthusiastic messenger and Mars throws dramatic tantrums with its backward dancing and brightness fluctuations. Jupiter maintains the sort of calm, stately presence that suggests it has seen everything the cosmos has to offer and remains unimpressed by petty theatrical displays. Jupiter simply is, night after night, year after year, following its majestic 12-year journey through the zodiac with the unhurried pace of genuine nobility. Standing outside on almost any clear night, you can spot Jupiter if it's above the horizon, not because it demands attention with flashy colours or dramatic brightness changes, but because of its steady, creamy white light that seems to glow with quiet confidence. Jupiter has the kind of brightness that doesn't shout for recognition, but simply waits patiently for you to notice it among the stellar crowd. Once you do spot it, Jupiter rewards your attention by being exactly where astronomical predictions say it should be, shining with exactly the brightness you'd expect, behaving with the sort of reliability that makes it a favourite among both beginning and experienced sky watchers. This consistency is one of Jupiter's most endearing qualities. Unlike Mars, which can vary in brightness by a factor of 75, Jupiter's brightness remains remarkably stable throughout its orbit. The planet's distance from Earth changes relatively little compared to the dramatic variations experienced by the inner planets, which means Jupiter maintains roughly the same appearance whether you observe it in January or July. It's like having that one friend who always looks essentially the same, whether you see them at a formal dinner or a casual picnic, reassuringly familiar and dependably themselves. There's something deeply comforting about Jupiter's predictability in a universe that often seems chaotic and unpredictable. When ancient sky watchers were struggling to understand Mercury's disappearing acts or Mars's backward loops, Jupiter provided a welcome anchor of stability. It moved, yes, but it moved with the sort of measured pace that suggested it knew exactly where it was going and was in no particular hurry to get there. Jupiter became the celestial equivalent of that calm, wise friend who never gets flustered by temporary setbacks and always seems to know that everything will work out in the end. Jupiter's 12-year orbital period creates a natural cosmic calendar that ancient astronomers found incredibly useful for tracking longer periods of time. The planet spends roughly 1 year in each zodiacal constellation, which means you can use Jupiter's position to mark the passage of years in a way that's much more convenient than trying to track the subtle yearly shifts of distant stars. If you were born when Jupiter was in Gemini, you could expect to see it return to that same constellation on your 12th birthday, your 24th, your 36th, and so on, creating a personal celestial anniversary that connects your earthly timeline to the grand cycles of the solar system. Picture yourself growing up in ancient Babylon, perhaps the son or daughter of a scribe who works in the great temple complex. Every clear night, you climb to the rooftop with your father or mother to observe the stars and learn the ancient art of astronomical prediction. Jupiter becomes your favourite celestial companion, not because it's the most dramatic or colourful, but because it's reliable. Year after year, you watch it progress through the constellations with the steady patience of a wise teacher, moving from the ram to the bull to the twins, with such regularity that you begin to use its position to remember important events in your own life. When Jupiter was in the Lion, you learned to write your name in cuneiform. When it moved into the Virgin, your baby sister was born. By the time Jupiter completed its stately procession through the entire zodiac and returned to the Ram, you had grown from a child into a teenager, and Jupiter's return felt like a cosmic pat on the head, acknowledging that you had successfully completed one full cycle of your education in the mysteries of the sky. The ancient Babylonians understood this cosmic rhythm so well that they built their long-term calendar systems around Jupiter's motion. They called the planet Marduk after their patron god, not the flashy, temperamental deity of war like Mars, but the wise ruler who brought order to chaos and maintained cosmic harmony. Marduk Jupiter became their celestial timekeeper for events that spanned decades or generations, a cosmic clock whose hands moved so slowly you could plan your entire life around its rhythm. The Greeks inherited this understanding and naturally associated Jupiter with Zeus, the king of their gods. But Zeus Jupiter wasn't the petty, jealous ruler of some mythologies. He was the mature, wise father figure who ruled through patience and wisdom rather than dramatic displays of power. When Greek astronomers looked up at Jupiter's steady light, they saw the celestial embodiment of good leadership, strong enough to command respect, but gentle enough to inspire loyalty rather than fear. There's something almost meditative about watching Jupiter's progress through the constellations if you have the patience for astronomical timescales. Unlike the rapid changes you can observe in the Moon's position from night to night, or even the week-to-week shifts of the inner planets, Jupiter's motion requires the sort of long-term attention that modern life rarely encourages. You might observe Jupiter in Taurus in March, then look again in June, and notice it's moved perhaps a third of the way toward Gemini, a subtle shift that rewards patient observation with the satisfaction of detecting genuine cosmic motion with nothing more than your eyes and memory. The Romans continued the tradition of associating Jupiter with their king of the gods, and they noticed something that added to Jupiter's reputation as a benevolent influence. Jupiter never goes retrograde in the dramatic loop-the-loop fashion of Mars. While Mars occasionally appears to change its mind and retrace its steps through the constellations, Jupiter maintains its steady eastward progress with only the gentlest of hesitations. When Earth's faster orbital motion creates the illusion of retrograde motion for Jupiter, it's a subtle, graceful arc rather than the sharp, dramatic loops that Mars creates. Even Jupiter's retrograde motion seems dignified, like a stately dance step rather than a moment of cosmic confusion. This steady behavior made Jupiter a natural choice for association with positive influences, stability, and beneficial change. Unlike Mars, which ancient astrologers associated with conflict and upheaval, Jupiter became the Great Benefic, the planetary influence you wanted to have prominent in your celestial forecast. Whether or not you believe in astrological influences, there's something psychologically comforting about having Jupiter visible in your evening sky. It's like having a calm, reassuring presence watching over the night. But perhaps the most remarkable thing about Jupiter is how it manages to be both the largest planet in our solar system and yet maintain such a gentle, unassuming presence in our sky. Jupiter is truly enormous, more massive than all the other planets combined, with a diameter more than 11 times that of Earth. If Jupiter were hollow, you could fit more than 1,300 Earths inside it. Yet from our earthly perspective, Jupiter appears as a modest, steady light that never overwhelms the night sky or demands attention through dramatic behavior. This paradox, enormous size combined with gentle presence makes Jupiter a perfect metaphor for the kind of quiet strength that doesn't need to prove itself through flashy displays. Jupiter's gravitational influence shapes the architecture of the entire outer solar system, shepherding comets and asteroids and protecting the inner planets from cosmic debris. Yet it does all of this cosmic housekeeping without fanfare or drama. Jupiter is the solar system's ultimate behind-the-scenes operator, maintaining order and stability while rarely calling attention to its essential work. When Galileo first turned his telescope toward Jupiter in 1610, he discovered something that revolutionized our understanding of the cosmos. 4 tiny stars that appeared to orbit Jupiter rather than being fixed in the celestial sphere. These Jovian moons, Io, Europa, Ganymede, and Callisto, provided the first direct evidence that not everything in the universe orbited Earth. Here was proof that other worlds could have their own systems of satellites, their own cosmic neighborhoods, operating independently of our terrestrial perspective. The discovery of Jupiter's moons was like finding out that your quiet, reliable friend secretly maintained an entire household of dependents, managing their complex schedules and needs with the same calm efficiency they brought to everything else. Jupiter, it turned out, wasn't just a solitary wanderer following its own path through the zodiac. It was the center of its own miniature planetary system, complete with moons that showed the same orbital regularity that characterized Jupiter's own motion around the Sun. These moons are still visible through modest binoculars or a small telescope, appearing as tiny points of light arranged in a line on either side of Jupiter's bright disk. Night after night, you can watch them change positions as they orbit their giant parent, sometimes disappearing behind Jupiter or being eclipsed by its shadow, sometimes appearing as tiny black dots silhouetted against Jupiter's cloud tops as they transit across the planet's face. It's like having your own miniature model of the solar system, complete with predictable orbital mechanics that you can observe and verify from your own backyard. Jupiter's role as a cosmic protector extends far beyond its own family of moons. The planet's enormous gravitational influence acts like a celestial bouncer, deflecting many comets and asteroids that might otherwise threaten the inner solar system. Astronomers have calculated that without Jupiter's protective presence, Earth would be struck by large cosmic projectiles far more frequently, potentially making the evolution of complex life much more difficult or impossible. Jupiter doesn't perform this protective service consciously, of course, but the effect is the same. Our giant neighbour quietly shields us from cosmic hazards while maintaining its own stately progress through the zodiac. Modern Jupiter watchers can appreciate both the planet's ancient role as a celestial timekeeper and its modern identity as the solar system's gentle giant. When you spot Jupiter hanging in the evening sky, you're seeing not just a bright planet, but the gravitational anchor that helps maintain the stability of our entire cosmic neighborhood. Jupiter's presence in the night sky connects you simultaneously to ancient astronomers who used its position to mark the passage of years, and to modern astrophysicists who understand its crucial role in making our solar system a safe place for life to flourish. There's also something profoundly peaceful about Jupiter's rhythm. In our age of instant communication and rapid change, Jupiter offers a different pace entirely, the pace of cosmic time, measured not in hours or days, but in years and decades. Watching Jupiter's slow progression through the constellations can be a form of meditation, a reminder that some things in the universe operate on timescales that dwarf human concerns, and yet somehow make our brief moment in the cosmos feel more precious rather than less significant. The next time you're outside on a clear night and you spot Jupiter's steady light among the stars, take a moment to appreciate the ancient wisdom embedded in its unhurried motion. Here's a world that has been following the same orbital path for billions of years, maintaining cosmic order through sheer gravitational presence, quietly protecting the inner solar system while never calling attention to its essential work. Jupiter embodies the kind of leadership that governs through example rather than force, strength that manifests as stability rather than drama, and wisdom that expresses itself through patience rather than haste. In a universe full of dramatic explosions, colliding galaxies, and cosmic catastrophes, Jupiter represents something equally important but much rarer: cosmic peace. It's the solar system's reminder that true power often operates quietly, that the most important influences are sometimes the most subtle, and that the greatest leaders are often those who never need to raise their voice to command respect. Jupiter reigns over the night sky not through intimidation, but through the sort of quiet competence that makes everyone else's job easier, and that makes the entire cosmic neighborhood a more stable, more livable place. If you've ever known someone who speaks very slowly and deliberately, choosing each word with such careful consideration that you find yourself leaning forward in anticipation, waiting for the next thought to emerge, then you'll understand Saturn's approach to celestial conversation. Saturn is the planet that operates on geological time, making Jupiter's 12-year orbital period seem positively hurried by comparison. Where Jupiter spends roughly 1 year in each zodiacal constellation, Saturn takes nearly 2.5 years to traverse the same cosmic territory, following its majestic 29.5-year journey around the Sun with a sort of patience that makes mountains seem restless. Standing outside on a clear night, scanning the sky for Saturn among the other wandering stars, you might initially overlook it entirely. Saturn doesn't announce itself with Venus's brilliant spectacle or Mars's distinctive ruddy glow. Instead, it hangs in the darkness with a subtle golden light that's bright enough to be easily visible but modest enough to blend in with the ordinary stars, unless you're specifically looking for planetary motion. Saturn has the astronomical equivalent of a quiet, thoughtful personality, present and significant, but never demanding attention through flashy displays or dramatic behavior. The golden tint that distinguishes Saturn from ordinary stars becomes more noticeable once you know what to look for. It's not the warm orange-red of Mars or the creamy white of Jupiter, but rather a subtle, honey-coloured glow that suggests something ancient and enduring. This coloration comes from Saturn's complex atmospheric chemistry and the way its clouds and haze layers interact with sunlight, creating that distinctive golden appearance that ancient observers found both beautiful and slightly mysterious. For ancient astronomers, Saturn presented a unique challenge that combined fascination with frustration. On one hand, Saturn's extreme slowness made it relatively easy to track over short periods. You could observe it for weeks or even months without detecting any obvious motion relative to the background stars. This stability made Saturn a reliable target for beginning skywatchers who were just learning to distinguish planets from stars. On the other hand, Saturn's glacial pace meant that understanding its complete orbital pattern required observations spanning decades or even generations. Picture yourself as a young astronomer in ancient Greece, perhaps a student of one of the great schools of philosophy where mathematical astronomy was considered essential knowledge. Your teacher points out Saturn to you on a clear autumn evening, explaining that this golden star is actually a wandering planet like Jupiter and Mars. You make careful note of Saturn's position relative to the nearby stars, determined to track its motion over the coming months. Week after week you observe Saturn faithfully, and week after week it appears to be in exactly the same place. You begin to wonder if your teacher made a mistake. Surely this is just an ordinary star, not a wandering planet at all. Only after months of patient observation do you finally detect Saturn's subtle drift against the stellar background. The motion is so gradual that it's like watching the hour hand of a clock. You know it must be moving, but the change is so slow that you can't actually see it happening. Eventually, though, you notice that Saturn has definitely shifted position relative to the star patterns, confirming that it is indeed a planet, just one that operates on an entirely different timescale than the more obvious wanderers. The ancient Babylonians, those master record keepers of astronomical phenomena, understood Saturn's challenge better than most. They developed a system of patient, multi-generational observations that allowed them to track Saturn's motion with remarkable precision. Babylonian astronomical records were passed down from teacher to student, from father to son, creating continuous data sets that spanned centuries. These long-term observations revealed that Saturn not only moved slowly through the zodiac, but that its motion followed predictable patterns that could be calculated mathematically. They called Saturn Ninurta, after their god of farming and agriculture, which seems appropriate for a celestial object whose rhythm matched the slow cycles of agricultural time rather than the rapid pace of daily human activities. Ninurta was associated with the hard, patient work of tending crops, waiting for seeds to sprout, and enduring the slow passage of seasons, all qualities that resonated with Saturn's unhurried progress through the constellations. The Greeks named Saturn Kronos after the father of Zeus, and this choice reflected their understanding of the planet's character as something ancient, fundamental, and connected to the deepest structures of time itself. Kronos was associated with the golden age of the past, and with the inexorable passage of time that eventually claims everything in the mortal world. The planet's slow motion made it a natural symbol for the sort of time that operates on cosmic rather than human scales, the time it takes for mountains to rise and erode, for species to evolve, for civilizations to rise and fall. There's something both humbling and oddly comforting about Saturn's temporal perspective. In our age of instant communication and rapid change, Saturn reminds us that some things operate on timescales that dwarf human concerns entirely. Watching Saturn's slow progression through the zodiac can be a form of meditation on deep time, a reminder that the universe operates according to rhythms much slower and more patient than our daily anxieties and ambitions. Roman astronomers inherited the Greek tradition and called the planet Saturn, after their god of agriculture and time. They noticed something that enhanced Saturn's reputation as a symbol of patience and endurance. Saturn was visible all night long during its opposition periods, rising at sunset and setting at sunrise, maintaining its steady presence throughout the dark hours like a celestial guardian watching over the sleeping world. Unlike the inner planets, which were always rushing toward or away from the sun, Saturn had the luxury of taking its time, appearing in the midnight sky with a sort of dignified presence befitting the most distant of the naked-eye planets. The Chinese astronomical tradition called Saturn the Earth Star, incorporating it into their five-element cosmological system, where it represented the element of Earth, stability, endurance, and the slow, patient processes that build and sustain civilization. Chinese astronomers developed sophisticated techniques for predicting Saturn's position decades in advance, using mathematical methods that accounted for the planet's slow but steady progress through their system of lunar mansions. One of the most remarkable aspects of Saturn's behaviour is how its extreme orbital period affects human perception of astronomical time. If you're lucky enough to live a long life, you might see Saturn complete 2 full orbits during your lifetime, possibly 3 if you pay attention to the sky from childhood through old age. This means that Saturn's return to any particular constellation is a genuinely rare event from a human perspective, something that happens only 2 or 3 times in an entire lifetime. Ancient cultures recognized this rarity and often treated Saturn's movements as markers of generational rather than annual time. When Saturn returned to the same constellation where it had been during someone's birth, that person would be approaching their 30th birthday, a significant milestone that marked the transition from youth to mature adulthood. This Saturn return, as it came to be known, became associated with major life transitions, periods of reflection and reorientation that matched the planet's unhurried but inexorable progress through the zodiac. There's something poetic about having a personal relationship with Saturn's orbital cycle. Unlike the rapid changes of the Moon or the yearly rhythm of the Sun, Saturn's cycle operates on the scale of human generations. The Saturn return that marks your 30th birthday connects you directly to the Saturn return your parents experienced at the same age, and forward to the return your children might someday experience. It's a celestial rhythm that links individual human lives to the larger patterns of family and cultural continuity. The slow pace of Saturn's motion also means that when Saturn does exhibit retrograde motion, the effect is particularly subtle and graceful. While Mars creates dramatic loops and Jupiter shows modest curves, Saturn's retrograde periods appear as gentle, elongated arcs that unfold over many months. Watching Saturn's retrograde motion requires the sort of patient, long-term observation that few modern sky watchers have the patience to maintain, but for those who do track it, Saturn's backward dance has an almost hypnotic quality, like watching a slow-motion version of the cosmic choreography that governs all planetary motion. When Galileo first observed Saturn through his primitive telescope in 1610, he discovered something that added yet another layer of mystery to the already enigmatic planet. Saturn appeared to have handles or ears, strange protrusions on either side that made it look unlike any other celestial object he had ever observed. Galileo's telescope wasn't powerful enough to resolve Saturn's rings clearly, so he interpreted what he was seeing as 2 large moons positioned on opposite sides of the planet. Even more mysteriously, these handles seemed to come and go over time. Sometimes Saturn appeared perfectly round like Jupiter or Mars, while at other times the strange appendages returned. Galileo was baffled by this behaviour, which seemed to violate every assumption about how celestial objects should behave. It wasn't until much later, with better telescopes, that astronomers realized they were seeing Saturn's rings from different angles as the planet slowly turned in its orbit, sometimes presenting the rings edge-on when they nearly disappeared, and sometimes at an angle when they were clearly visible. This discovery of Saturn's rings added an entirely new dimension to the planet's already considerable mystique. Here was not just the slowest and most distant of the naked-eye planets, but a world surrounded by a structure so delicate and beautiful that it challenged every assumption about how planets should look. The rings transformed Saturn from merely the most patient planet into something genuinely alien, a world that operated according to physical laws that seemed to produce impossible beauty on a cosmic scale. Modern Saturn watchers can appreciate both the planet's ancient role as a marker of deep time and its modern identity as one of the most visually spectacular objects in the solar system. Even a modest telescope reveals Saturn's rings clearly, transforming that modest golden star into a jewel of impossible delicacy floating in the darkness of space. The rings appear as a thin, bright line extending on either side of the planet, occasionally showing subtle divisions and variations in brightness that hint at their incredibly complex structure. There's something almost magical about seeing Saturn's rings for the first time through a telescope. The sight is so unexpected, so unlike anything in terrestrial experience, that many people initially assume they're looking at some kind of optical illusion or telescope defect. The rings seem too delicate, too perfectly arranged, too geometrically precise to be real. Yet there they are, a structure spanning hundreds of thousands of kilometers, made up of countless particles of ice and rock, each following its own orbital path around Saturn with clockwork precision. The rings also change their appearance over Saturn's long orbital period, presenting different angles to Earth as the planet slowly turns in its orbit. Sometimes the rings appear wide open, displaying their full glory and revealing subtle divisions and colour variations. At other times, they appear edge-on and nearly invisible, reducing Saturn to just another ordinary-looking planet. This cycle of ring visibility adds another layer to Saturn's already complex temporal rhythm. Not only does the planet take nearly 30 years to complete its orbit, but the appearance of its most distinctive feature changes dramatically over that same period. Beyond the visual spectacle, Saturn's rings represent something profound about the nature of cosmic order and complexity. Each particle in the rings follows Newton's laws of motion with perfect precision, yet the collective behavior of billions of particles creates structures of incredible beauty and complexity. The rings are simultaneously chaotic, composed of countless individual objects following their own paths, and ordered, forming elegant patterns that persist for millions of years. They're a perfect metaphor for the way simple physical laws can generate emergent complexity and beauty on cosmic scales. Saturn's family of moons adds yet another dimension to the planet's complexity. While Jupiter's 4 largest moons are easily visible through binoculars, Saturn's major moon Titan requires a modest telescope to spot, but it's worth the effort. Titan is larger than Mercury, and possesses a thick atmosphere and lakes of liquid methane on its surface, an alien world that might harbour exotic forms of life, adapted to conditions utterly unlike anything on Earth. Observing Titan orbit Saturn over the course of weeks or months provides another way to appreciate the slow, stately rhythms that characterise everything about the Saturn system. The modern understanding of Saturn as a gas giant with a density so low that it would float in water adds another layer of mystery to a planet that was already the most enigmatic of the classical wanderers. Saturn appears solid and substantial through a telescope, but it's actually composed mostly of hydrogen and helium, with an internal structure so exotic that it challenges our earthbound intuitions about what planets should be like. The golden colour we see is just the top layer of an atmosphere that extends downward for thousands of kilometres, gradually transitioning from gas to liquid to possibly solid, at pressures and temperatures that make the deepest ocean trenches seem comfortable by comparison. There's something appropriate about the fact that Saturn, the planet that taught ancient astronomers patience through its slow orbital motion, continues to challenge and surprise modern scientists with its complex ring dynamics, exotic chemistry, and alien moon systems. Saturn rewards careful long-term study just as it always has, revealing its secrets gradually to those willing to invest the time and attention that its mysteries deserve. The next time you spot Saturn's modest golden light in the night sky, take a moment to appreciate the cosmic patience it represents. Here's a world that has been following the same orbital path for billions of years, accompanied by its retinue of rings and moons, slowly but inexorably tracing its stately course through the zodiac. Saturn embodies the sort of cosmic time that operates on scales far beyond human experience, yet somehow makes our brief moment in the universe feel more meaningful rather than less significant. In our rapid-fire age of instant everything, Saturn offers a different pace entirely, the pace of geological change, of evolutionary adaptation, of the slow accumulation of wisdom that comes only through patient observation and long experience. Saturn reminds us that some of the most beautiful and complex structures in the universe emerge not through rapid change, but through the patient operation of simple laws over immense periods of time. It's a lesson in cosmic humility that comes wrapped in golden light and delivered at the stately pace that has characterized Saturn's motion since the solar system formed. Have you ever watched dancers on a stage from far up in the theatre balcony, where individual movements blur together into graceful patterns that reveal the underlying choreography more clearly than if you were sitting in the front row? The dance of the planets across our sky follows this same principle. From our earthly vantage point, the complex orbital mechanics of 5 different worlds moving at different speeds and distances creates a cosmic ballet that unfolds over months, years, and decades, with movements so subtle and interconnected that ancient astronomers spent centuries learning to read its intricate steps. The basic movements of this celestial dance have names that sound almost like calls in a cosmic square dance: conjunction and opposition, retrograde and direct motion, elongation and syzygy. But unlike human choreography, which exists for entertainment or artistic expression, the planetary dance follows the inexorable laws of orbital mechanics, playing out the same fundamental patterns over and over again, with variations that depend on the complex timing of worlds moving in elliptical paths around the Sun at different speeds and distances. Understanding this dance begins with grasping the concept of planetary opposition, those special times when a planet appears directly opposite the Sun in Earth's sky. Picture yourself standing outside at midnight during one of these oppositions, perhaps when Mars is at its magnificent best. The Sun is on the far side of Earth, completely out of sight below the horizon, while Mars hangs directly overhead at the zenith, blazing with that distinctive ruddy glow that has captivated sky watchers for millennia. This geometry, Earth positioned between the Sun and the outer planet, creates the conditions for the most spectacular planetary viewing, because the planet is simultaneously at its closest approach to Earth and showing us its fully illuminated face. Opposition is like the cosmic equivalent of a full moon, except instead of our natural satellite being fully lit by the Sun, it's an entire world in another orbit reaching the moment when Earth's position allows us to see it at its absolute best. During opposition, planets rise at sunset, reach their highest point in the sky at midnight, and set at sunrise, providing the entire night for observation and creating those memorable celestial displays that can turn casual observers into lifelong astronomy enthusiasts. The timing between oppositions follows predictable patterns that ancient astronomers learned to calculate with remarkable precision. Mars reaches opposition roughly every 26 months, Jupiter every 13 months, and Saturn every year and 2 weeks. These intervals, called synodic periods, represent the time it takes for Earth's faster orbital motion to lap the outer planets, like runners on a track, where the inner runner periodically overtakes those in the outer lanes. But opposition is just one movement in the planetary dance. At the opposite extreme lies conjunction, when a planet appears to pass behind or in front of the Sun from Earth's perspective, disappearing entirely into the solar glare. Superior conjunction occurs when an outer planet like Mars or Jupiter is on the far side of the Sun from Earth, while inferior conjunction happens when Venus or Mercury passes between Earth and the Sun. During these periods, the planets vanish from our night sky for weeks or months, hidden in the overwhelming brightness of our star like actors stepping behind a brilliantly lit backdrop. The ancient Greeks, who loved their geometric explanations for celestial phenomena, understood that these oppositions and conjunctions represented the fundamental breathing of the cosmic mechanism. They recognized that the planets weren't randomly wandering through the sky, but were following predictable geometric relationships that could be calculated mathematically. This insight transformed astronomy from mere sky-watching into a true science capable of making accurate predictions about future celestial events. Between opposition and conjunction, the outer planets trace their paths through a more complex movement that includes one of the most beautiful and puzzling aspects of planetary motion: retrograde loops. We touched on this when discussing Mars, but the phenomenon affects all the outer planets and represents one of the most elegant demonstrations of how orbital mechanics can create the illusion of complexity when viewed from a moving platform. Picture the retrograde dance as it unfolds over several months of patient observation. Let's say you're tracking Jupiter's progress through the constellation Taurus. Night after night, Jupiter moves steadily eastward relative to the background stars, following its normal direct motion through the zodiac. Then, as Earth begins to catch up with Jupiter in the cosmic racetrack, something magical happens. Jupiter appears to slow down in its eastward motion, then stops entirely for several nights, hovering in the same spot among the stars, like a cosmic dancer pausing mid-performance. Then begins the backward dance. Jupiter starts moving westward, retracing its path through Taurus in what astronomers call retrograde motion. This backward movement continues for several months, creating a graceful loop in Jupiter's path against the stellar background. Eventually, Jupiter stops its westward motion, pauses again, then resumes its original eastward journey, continuing on through Taurus as if nothing unusual had happened. This retrograde loop occurs because Earth, traveling in the inner lane of the solar system's highway, periodically overtakes the outer planets like a faster car passing slower traffic on the freeway. During the passing maneuver, the outer planet appears to move backward relative to the distant background of stars, just like roadside objects seem to drift backward when you overtake a slower vehicle on a highway. Once Earth completes the pass and moves ahead in its orbit, the outer planet resumes its normal apparent motion across the sky. The beauty of retrograde motion lies not just in its graceful appearance, but in how it reveals the underlying geometry of the solar system. Each planet creates its own characteristic retrograde loops. Mars makes sharp, dramatic curves that can create almost triangular paths. Jupiter traces broader, more leisurely arcs, while Saturn's loops are so gradual and elongated that they unfold over many months like slow-motion calligraphy written across the constellations. Ancient astronomers, working within the Earth-centered model of the universe, struggled for centuries to explain these retrograde loops. The most successful attempt was Ptolemy's system of epicycles, complex arrangements of circles riding on circles that could mathematically reproduce the observed planetary motions. While ingenious, this system was so complicated that it resembled a cosmic Rube Goldberg machine, with dozens of interlocking circular motions required to explain the movement of just 5 planets. The elegant simplicity of the heliocentric explanation that retrograde motion is simply a perspective effect caused by Earth's orbital motion represents one of the great triumphs of astronomical insight. Copernicus's realization that placing the Sun at the center of the solar system made retrograde motion a natural consequence of orbital geometry rather than an elaborate puzzle, solved one of astronomy's oldest mysteries with breathtaking simplicity. But the planetary dance includes more than just oppositions, conjunctions, and retrograde loops. Some of the most spectacular celestial events occur when multiple planets participate in the cosmic choreography simultaneously, creating what astronomers call planetary conjunctions. These occur when two or more planets appear close together in the sky from Earth's perspective, often creating memorable celestial displays that have inspired both scientific investigation and mythological interpretation throughout human history. The most famous of these planetary meetings are the great conjunctions of Jupiter and Saturn, which occur roughly every 20 years when Earth's faster orbital motion allows us to witness these two giant worlds appearing to pass close by each other in the sky. From our earthly perspective, Jupiter and Saturn seem to approach each other over several months, eventually appearing so close that they might look like a single bright star to casual observers, then slowly separate again as their different orbital speeds carry them apart. These great conjunctions have been observed and recorded for millennia, and they've often been associated with significant historical events or interpreted as omens of major changes in human affairs. The conjunction of 1603, visible just before the death of Queen Elizabeth I and the ascension of James I to the English throne, was widely interpreted as a cosmic signal of the changing times. The conjunction of 1980 to 1981 occurred during a period of significant global political changes, leading some modern astrologers to claim it as confirmation of the planet's continuing influence on earthly affairs. More rarely, three or more planets can appear close together in what astronomers call a planetary gathering, or, in extreme cases, a planetary alignment. While true alignments where all visible planets appear in a perfectly straight line are extremely rare, perhaps occurring once every few centuries, looser gatherings where several planets appear in the same general region of sky are more common and can create spectacular displays for sky watchers lucky enough to witness them. The timing of these multi-planet events follows the complex mathematics of orbital mechanics, where the periods of different planets must align in just the right way to create the appearance of celestial cooperation. Venus and Jupiter, for example, might appear close together several times a decade, but adding Mars to create a three-planet gathering happens much less frequently, and including Saturn or Mercury makes such events even rarer and more spectacular. One of the most beautiful aspects of planetary conjunctions is how they can transform familiar sky patterns temporarily, creating new configurations that might not repeat for decades or centuries. A tight conjunction between Venus and Jupiter can create what appears to be an extraordinarily brilliant star in the evening or morning sky, bright enough to cast shadows and visible even in urban areas with significant light pollution. These events can be so spectacular that they generate UFO reports from people unfamiliar with astronomical phenomena, or inspire rumours of unusual celestial visitations. The seasonal timing of planetary events adds another layer of complexity and beauty to the cosmic dance. The best Mars oppositions occur during late summer and early autumn in the northern hemisphere, when the red planet hangs high in the midnight sky during comfortable observing weather. Jupiter's oppositions cycle through all seasons over the course of its 12-year orbit, sometimes gracing winter skies with steady golden light, other times providing a brilliant summer companion for warm evening observations. Saturn's even longer orbital period means that its oppositions progress slowly through the calendar, spending several years visible during winter months, then gradually shifting to spring, summer, and autumn appearances as its 30-year orbit carries it through different regions of the zodiac. This slow seasonal progression means that Saturn's most favourable viewing conditions change gradually over decades, creating generational differences in when and how different age groups first encounter the ringed planet. Venus and Mercury, confined as they are to the vicinity of the Sun, create their own seasonal patterns of visibility that depend on the complex interplay between their orbital periods and Earth's yearly journey around the Sun. Venus's most spectacular evening star appearances occur during certain seasons that depend on the orientation of the ecliptic, while Mercury's brief appearances favour different times of year for morning versus evening visibility. Understanding these patterns transforms casual skywatching into a form of cosmic literacy, allowing you to anticipate when different planets will be well placed for observation and to appreciate the underlying astronomical causes behind the celestial displays you witness. When you spot Venus and Jupiter appearing close together in the evening twilight, you're not just seeing a beautiful sight. You're witnessing a specific geometric arrangement of three worlds moving in their orbits around the Sun, a configuration that won't repeat exactly for many years. The predictability of the planetary dance also means that astronomers can calculate favourable viewing opportunities years or even decades in advance, creating detailed predictions of oppositions, conjunctions, and other celestial events that help both amateur and professional observers plan their activities. Modern planetarium software can show you exactly how the sky will look on any future date, allowing you to preview coming attractions in the cosmic theatre and mark your calendar for the most spectacular shows. But perhaps the most remarkable aspect of the planetary dance is how it connects modern observers to thousands of years of human astronomical tradition. When you watch Mars execute one of its retrograde loops, you're seeing exactly the same apparent motion that mystified Babylonian astronomers 3,000 years ago. The conjunction of Jupiter and Saturn that you might observe this decade follows the same orbital mechanics that created the Great Conjunction witnessed by Johannes Kepler in 1603, or the one that might have inspired the biblical account of the Star of Bethlehem over 2 millennia ago. The planetary dance continues today with the same mathematical precision that has governed it since the solar system formed, but our understanding of the choreography has deepened immeasurably. Where ancient observers saw mysterious wandering stars following incomprehensible paths across the sky, we now recognize the elegant expression of gravitational physics operating on a cosmic scale. The same laws that govern the fall of an apple to Earth also choreograph the dance of planets across our sky, creating patterns of motion that are simultaneously predictable and beautiful, mechanical and poetic. The next time you're outside on a clear night and you spot one of the wandering stars, take a moment to appreciate your position as a member of the audience for this cosmic performance. You're watching a dance that has been unfolding for billions of years, following steps choreographed by the fundamental forces of nature, performed by worlds that dwarf our earthly stage, yet follow the same physical laws that govern the motion of every object in our experience. In learning to read the steps of this celestial dance, you join the long tradition of humans who have found wonder, beauty, and deep satisfaction in understanding the graceful mechanics of our cosmic neighbourhood. There's something wonderfully intimate about developing a personal relationship with the night sky, learning to recognize the planets not as distant abstractions mentioned in astronomy books, but as familiar companions whose seasonal comings and goings become as anticipated and comforting as the first spring robin or the last autumn leaf. This relationship begins with a simple decision to step outside regularly, look up, and pay attention. Not with the frantic urgency of someone trying to master a new skill quickly, but with the patient curiosity of someone settling into a long and rewarding conversation with the cosmos. The beauty of becoming a planet watcher lies in how it operates entirely on human timescales, while connecting you to rhythms far grander than daily concerns. Unlike the professional astronomy you might see in documentaries, which often deals with objects so distant and faint they require million-dollar telescopes even to detect. Following the planets uses the same basic equipment that has served skywatchers for thousands of years. Your eyes, your memory, and the willingness to step outside on clear nights and notice what's changed since last week. Winter offers perhaps the most forgiving introduction to serious planet observation, at least if you live somewhere with cold, clear nights. The long darkness provides plenty of time for observation, and there's something almost magical about discovering that the cold air often creates the most spectacular viewing conditions, as if the universe is compensating for the discomfort by offering its clearest, steadiest skies. When Jupiter graces winter evenings, hanging above the brilliant constellation Orion like a golden crown jewel, even a few minutes outside can reward you with sights that make the cold entirely worthwhile. Picture yourself on a February evening, bundled up against the winter chill but determined to spend some quality time with the night sky. You step outside around 9 o'clock, and the first thing you notice is how much brighter the stars seem on these crisp winter nights. As your eyes slowly adjust to the darkness, a process that requires genuine patience in our age of instant everything, the sky gradually reveals more and more detail, and there, hanging steady and golden in the southern sky, is Jupiter's unmistakable glow. Even through a modest pair of binoculars, those wonderfully democratic instruments that bridge the gap between casual skywatching and serious astronomy, Jupiter reveals its secrets willingly. 4 tiny points of light arrange themselves in a line on either side of the bright planetary disk, and you realize you're looking at Jupiter's largest moons, the same celestial companions that Galileo first spotted over 4 centuries ago. Night after night, these moons change positions in their endless dance around Jupiter, sometimes disappearing behind the planet or being eclipsed by its shadow, creating a miniature solar system that you can watch evolving from your own backyard. Spring brings its own gifts to the planet watcher, often in the form of Venus making one of its spectacular evening star appearances. When Venus reaches its best spring showing, it can hang in the western sky for hours after sunset, providing what astronomers like to call the evening star experience in all its glory. These spring Venus displays are particularly memorable because they coincide with the return of comfortable evening weather, when stepping outside becomes a pleasure rather than an Arctic expedition. The challenge of spring planet watching lies partly in the season's notorious weather patterns. Spring can be delightfully unpredictable, with crystal clear skies one evening followed by clouds, rain, or atmospheric haze the next. This uncertainty makes it particularly important to seize every clear night, because you never know when the next opportunity will present itself. There's something almost poetic about how spring weather mirrors the transitional nature of the season. Just as the natural world is awakening from winter dormancy, the sky itself seems to be shifting between different moods and possibilities. Summer transforms planet watching into an entirely different experience. The shorter nights mean less total observing time, but the warm weather more than compensates by making outdoor observation genuinely comfortable. Summer is often Mars season, particularly during those spectacular oppositions when the red planet reaches its blazing best during warm July and August nights. There's something deeply satisfying about lying back on a blanket under summer stars, with Mars burning overhead like a cosmic ember, spending hours exploring the night sky without any concern about frostbite or hypothermia. The summer Milky Way provides the most spectacular backdrop imaginable for planetary observations, stretching across the warm night sky like a celestial river of starlight that's visible from reasonably dark locations. When planets appear projected against this stellar abundance, the contrast between the nearby wandering stars and the distant galactic multitudes becomes beautifully obvious. Mars hanging in front of the summer Milky Way looks unmistakably different from the background stars, brighter, steadier, and possessed of that distinctive ruddy glow that no genuine star can duplicate. Autumn brings what many consider the optimal conditions for planet observation. The nights are growing longer and more comfortable, the oppressive heat of summer has faded, but winter's bitter cold hasn't yet arrived, and the autumn atmosphere often provides exceptionally steady viewing conditions. This atmospheric stability, caused by more consistent temperature and humidity patterns, reduces the twinkling that can make observations difficult and allows planetary disks to appear sharp and well-defined, even through modest telescopes. Saturn often graces autumn skies during its most favourable periods, hanging among the autumn constellations like a golden jewel in the seasonal crown of stars. Through even a small telescope, Saturn's rings become clearly visible, transforming that modest golden point of light into one of the most spectacular sights in the entire solar system. The first time you see Saturn's rings clearly is genuinely unforgettable, a moment when the abstract concepts of astronomy suddenly become tangible reality floating in the darkness above your head. Learning to navigate the night sky without constantly consulting apps or star charts develops naturally over time, much like learning to recognize faces in a crowd. At first, all the stars might seem equally anonymous, but gradually you begin to notice the distinctive patterns of major constellations, the subtle differences in stellar colors and brightness, and most importantly when a bright star appears where you don't remember seeing one before. This growing familiarity transforms casual skywatching into something much more personal and rewarding. Binoculars deserve special recognition as the perfect instrument for developing a relationship with the planets. While telescopes can provide higher magnification and more detailed views, binoculars offer several advantages that make them ideal for patient, long-term observation. They're portable enough to use whenever the mood strikes, relatively inexpensive, easy to use, and most importantly, they provide views that are bright, sharp, and oriented the same way your naked eyes see the sky. A decent pair of binoculars, perhaps 7 by 50 or 10 by 50, where the first number indicates magnification and the second shows the diameter of the front lenses, will reveal Jupiter's 4 largest moons clearly, show Venus's phases when it's close to Earth, and make the subtle colour differences between planets much more obvious than they appear to naked eyes. These same binoculars will also open up the deep sky, making star clusters and nebulae visible and providing years of astronomical entertainment beyond just planet watching. The seasonal dance of planetary visibility follows patterns that become as familiar as the weather, once you've watched them for a full cycle. Mars reaches opposition roughly every 2 years, creating a rhythm where the red planet alternates between months of spectacular visibility and long periods of absence when it's lost in the sun's glare. Jupiter's oppositions occur more frequently, about every 13 months, meaning Jupiter is well placed for evening observation for several months each year, though the timing slowly shifts through the seasons over Jupiter's 12-year orbital journey. Saturn's opposition cycle repeats annually, but because the ringed planet takes nearly 30 years to complete its orbit, Saturn's seasonal appearances change very slowly. If Saturn is prominent in summer skies, when you first start watching, it will remain a summer planet for several years to come, only gradually shifting to autumn, then winter, then spring visibility over the course of its long journey around the Sun. This leisurely seasonal progression means that different generations often associate Saturn with different times of year, depending on when they first discovered the night sky. Venus and Mercury create their own intricate patterns of visibility, sometimes dominating the morning or evening sky with brilliant displays, other times vanishing entirely into the sun's glare for weeks or months. Learning to anticipate these appearances and disappearances becomes part of the rhythm of regular sky watching, like knowing when to expect the first flowers of spring or the peak colours of autumn leaves. Weather plays a more important role in planet watching than you might initially expect. Understanding your local climate patterns can help you make the most of favourable conditions and avoid the frustration of planning observing sessions during predictably poor weather. In many locations, certain seasons consistently offer better viewing than others due to atmospheric stability, humidity levels, or prevailing wind patterns that affect how steady and clear the air appears to distant celestial objects. Urban planet watching presents its own unique challenges and surprising opportunities. Light pollution, which can completely wash out faint deep sky objects, affects planetary observation much less severely, because planets are bright enough to shine through even moderately light-polluted skies. Venus, Jupiter and Mars during opposition remain clearly visible from city centres, though their colours and subtler details become more apparent when viewed from darker locations. The key lies in understanding which celestial objects can triumph over urban lighting and which require expeditions to darker skies. The International Space Station deserves mention as perhaps the most spectacular addition to the modern skywatcher's repertoire. While not technically a wandering star in the classical sense, the ISS creates one of the most dramatic sights available to anyone willing to step outside at the right time. The station appears as a brilliant, steady light, moving steadily across the sky, typically taking several minutes to cross from horizon to horizon, while shining with a brightness that can rival Venus or Jupiter. ISS passes are predictable and can be calculated years in advance, making it possible to plan viewing sessions around particularly spectacular appearances. There's something deeply moving about watching the space station cross overhead, knowing that human beings are living and working in that moving point of light, extending our presence beyond Earth into the realm where planets dance. It connects the ancient tradition of sky watching to the modern reality of human space exploration in a way that makes both feel more immediate and meaningful. Keeping simple records of your planetary observations can enhance the experience immeasurably, though it shouldn't feel like homework or a scientific obligation. A small notebook where you occasionally jot down what you've seen, when you saw it, and perhaps how it made you feel creates a personal astronomical diary that becomes increasingly precious over time. Looking back at notes from previous seasons can reveal patterns and changes that weren't obvious when the individual observations were made, and it connects your present sky watching to your past experiences in ways that pure memory often cannot. The social aspect of planet observation add dimensions that solo watching cannot provide. Sharing spectacular sights with family, friends, or fellow skywatchers creates memories that last far beyond the celestial events themselves. There's something particularly magical about introducing someone to Saturn's rings for the first time, or showing a child how to spot Venus in the evening twilight, or gathering with other observers to watch Mars reach opposition during a perfect autumn night. Children often make the most enthusiastic planet observers because they haven't yet developed the adult tendency to overthink simple pleasures. Their natural curiosity and patience for repeated observations can put grown-ups to shame, and they often notice details that more experienced observers might overlook. Teaching a child to follow Jupiter through the constellations over several months, or to track Venus's transformation from evening star to morning star, plant seeds that may bloom into lifelong astronomical interests. Photography has become an increasingly popular way to document planetary observations, though it requires a somewhat different approach than visual watching. Even simple smartphone cameras can capture bright conjunctions or planetary groupings, creating lasting records of celestial events that supplement memory and written notes. More sophisticated photography can reveal details invisible to the naked eye, but it shouldn't replace the fundamental pleasure of simply looking up and appreciating what you see with your own eyes. The integration of modern technology with ancient observational traditions offers the best of both worlds for contemporary planet watchers. Smartphone apps can help identify which planets are visible and where to look for them, but the actual experience of standing under the night sky and watching distant worlds move through space remains as immediate and personal as it was for our ancestors. Online communities provide forums for sharing observations and learning from more experienced watchers, but they cannot replace the direct sensory experience of cold air on your face and starlight in your eyes. Perhaps the most important practical advice for anyone beginning a year-long journey of planet watching is simply this: be patient with yourself and with the sky. Not every clear night will offer spectacular views, and not every planetary event will live up to expectations. Some evenings you'll step outside full of anticipation only to find the planets hidden behind unexpected clouds or rendered invisible by atmospheric haze. Other nights, when you're not expecting anything special, the sky will surprise you with Venus and Jupiter hanging like paired jewels in the twilight, or Mars glowing with unusual intensity above the eastern horizon. The rewards of regular planet watching accumulate slowly, like interest in a savings account or strength from regular exercise. Each observation adds to your growing familiarity with celestial rhythms. Each clear night deepens your connection to the cosmos, and each seasonal cycle enhances your appreciation for the patient dance of worlds that has been unfolding above our heads since long before humans existed to witness it. The planets are patient teachers, willing to reveal their secrets to anyone who takes the time to pay attention, and they offer a form of natural meditation that connects us to rhythms far grander and more enduring than the hurried pace of modern life. As our gentle journey through the wandering paths of the planets draws toward its close, there's something profoundly moving about the realization that the same celestial dance we've been exploring together has been unfolding above human heads for thousands upon thousands of years. The Jupiter that hangs in tonight's sky is the same Jupiter that guided ancient Babylonian farmers through their seasonal cycles, the same golden wanderer that inspired Greek philosophers to contemplate the mathematical harmonies of the cosmos, and the same steady beacon that will continue its patient journey through the zodiac long after our own brief moment in the cosmic story has passed. Standing outside on a clear night, looking up at Venus blazing in the western twilight, or Mars glowing with its distinctive ruddy light among the autumn stars, you become part of an unbroken chain of human experience that stretches back to the very beginnings of consciousness itself. The photons touching your eyes tonight began their journey across the solar system days, minutes, or hours ago, depending on which wandering star has caught your attention, but they're carrying the same light that has been illuminating human faces turned skyward since our ancestors first wondered about those bright points that refuse to stay in their proper places among the fixed stars. This continuity across time and culture represents something rare and precious in our modern world, where so much changes so rapidly that we sometimes lose track of the deeper rhythms that connect us to our past and future. The planetary dance operates on timescales that dwarf political upheavals, technological revolutions, and social transformations, providing a kind of cosmic stability that reminds us of our place in the much larger story of the universe itself. When ancient astronomers in places like Babylon, Alexandria, or Cordoba looked up at Saturn's golden glow and patiently tracked its slow progression through the constellations, they were participating in the same fundamental human activity that draws modern sky watchers outside on clear nights. The tools have become more sophisticated. Smartphone apps can now pinpoint planetary positions with precision that would have amazed Ptolemy or Copernicus. But the essential experience remains unchanged. Human beings looking up at the night sky with wonder and curiosity, trying to understand their relationship to the cosmos that surrounds them. There's something deeply democratic about this shared experience across centuries and cultures. The planets don't care about your nationality, your social status, your religious beliefs, or your level of formal education. Venus shines just as brilliantly for a child discovering the evening star for the first time as it does for a professional astronomer with decades of experience. Jupiter's moons dance around their giant parent with the same orbital precision, whether they're being observed through a cardboard tube telescope built in a garage or through a $1 million instrument atop a mountain observatory. This accessibility of planetary observation represents one of astronomy's greatest gifts to humanity. While much of modern science requires specialized equipment, advanced mathematics, or years of technical training to appreciate fully, the basic wonder of watching worlds move through space requires nothing more than the willingness to step outside and look up. It's science at its most fundamental level. Direct observation of natural phenomena, patient attention to changing patterns, and the gradual accumulation of understanding through repeated experience. The planets have also served as remarkable teachers throughout human history, patiently revealing the secrets of orbital mechanics to any civilization willing to observe carefully and think systematically about what they were seeing. Mars's retrograde loops taught us that simple geometric explanations could account for apparently chaotic behavior. Venus's phases provided crucial evidence for the heliocentric model of the solar system. Jupiter's moons demonstrated that not everything in the universe orbited Earth, fundamentally changing our understanding of our cosmic position. Each of these discoveries required nothing more sophisticated than careful observation, mathematical reasoning, and the willingness to question assumptions that had been accepted for centuries. The planets were generous teachers, offering their lessons to anyone with the patience to watch and the intellectual courage to follow the evidence wherever it might lead, even when it challenged comfortable beliefs about humanity's central place in the cosmic scheme. The modern understanding of planetary motion as the expression of gravitational physics operating on a cosmic scale adds layers of beauty and meaning to the ancient observations without diminishing their wonder. When you watch Jupiter execute one of its gentle retrograde loops, you're not just seeing a puzzling celestial phenomenon, you're witnessing the elegant choreography of worlds governed by the same physical laws that keep your feet planted firmly on the ground and cause apples to fall from trees. This unity of physical law, operating from the smallest scales of quantum mechanics to the largest structures of galactic clusters, represents one of science's most profound insights. The universe operates according to comprehensible principles that human minds can understand and describe mathematically. The planetary dance that mystified ancient observers turns out to be a perfect expression of these universal principles, rendered visible in the slow-motion ballet of worlds orbiting a star. Yet understanding the physics behind planetary motion doesn't diminish the emotional and spiritual resonance of the experience. If anything, knowing that Venus's brilliant appearances follow predictable orbital mechanics makes the sight of the evening star hanging in the twilight even more moving, not less. You're not just seeing a beautiful celestial object. You're witnessing the precise operation of cosmic clockwork that has been keeping perfect time for billions of years, will continue operating long after our sun has evolved beyond recognition, and connect our small planet to the fundamental forces that shape the entire universe. The cultural meanings that different civilizations have found in planetary movements add another dimension to this ongoing story. While we now understand that Mars's red colour comes from iron oxide on its surface rather than divine blood, and that Jupiter's stately progress through the zodiac reflects orbital mechanics rather than royal decree, these ancient interpretations remind us that human beings have always found profound significance in the night sky. The planets have served as calendars, navigation aids, agricultural timekeepers, sources of mythological inspiration, and symbols of cosmic order for thousands of years. Modern astronomy hasn't eliminated the need for meaning and significance in our relationship with the cosmos. It has simply shifted the source of that meaning from supernatural interpretation to scientific understanding combined with aesthetic and philosophical appreciation. When you spot Venus and Jupiter appearing close together in the evening sky during one of their spectacular conjunctions, you might understand the orbital geometry that creates this appearance, while simultaneously feeling the same sense of wonder and cosmic connection that inspired ancient observers to see divine messengers dancing in the heavens. The future of planetary observation holds both continuity and change. The wandering stars will continue following the same gravitational choreography that has governed their motion since the solar system formed, but our to observe and understand their dance will undoubtedly continue evolving. Space missions will bring us increasingly detailed knowledge of planetary surfaces, atmospheres, and histories. Advanced telescopes will reveal exoplanets orbiting distant stars, expanding our understanding of how common planetary systems might be throughout the galaxy. Yet the fundamental human experience of stepping outside on a clear night and spotting the wandering stars with unaided eyes will remain as immediate and personally meaningful as it has always been. No amount of technological advancement can replace the simple pleasure of recognizing Jupiter's steady glow among the winter constellations, or the satisfaction of watching Venus transform from evening star to morning star over the course of many months, or the excitement of catching Mercury during one of its brief but spectacular appearances in the twilight sky. The planets also remind us of our cosmic context in ways that are both humbling and inspiring. We live on one small world orbiting an ordinary star in a galaxy containing billions of similar stars, many of which likely have their own planetary systems with their own wandering stars visible from their own night skies. The dance we observe from Earth is just one local performance in a cosmic symphony that includes countless other planetary systems, other worlds, and perhaps other observers looking up at their own wandering lights with the same mixture of curiosity and wonder that drives our own astronomical interests. This perspective shift from the ancient view of Earth as the centre of everything to our modern understanding of our place as inhabitants of one planet among many doesn't diminish human significance, it expands it. We're not just observers of the cosmic dance, we're participants in it, riding our own planet through space as it follows its annual orbit around the Sun, spinning once each day to create the rhythm of night and day, tilted at just the right angle to give us the seasonal variations that make our world habitable and beautiful. The planetary observations that began as practical necessities for ancient civilizations, tracking time, predicting seasons, navigating by celestial landmarks, have evolved into sources of purely aesthetic and intellectual pleasure for modern skywatchers. We don't need to observe Jupiter's position to know when to plant crops or Saturn's location to calculate the date, but we still find deep satisfaction in following their patient progress through the constellations, connecting ourselves to rhythms much larger and more enduring than the rapid pace of contemporary life. Perhaps this is one of the greatest gifts the planets offer to our modern world, the opportunity to slow down, to pay attention to changes that unfold over weeks and months rather than seconds and minutes, to connect with patterns of motion that have been constant since long before human civilization existed. In an age of instant communication and rapid change, the planets provide a different temporal framework entirely, one that encourages patience, long-term thinking, and appreciation for the gradual accumulation of small changes over extended periods. The community aspects of planet watching also deserve recognition as the hobby continues to evolve in our connected world. Online forums, social media groups, and astronomy clubs provide ways for observers to share their experiences, compare observations, and learn from others who share their passion for the night sky. Yet these digital connections supplement rather than replace the fundamental solitary experience of standing under the stars and following the ancient dance with your own eyes. Children who discover the planets today will grow up with access to images from space missions, sophisticated computer models of orbital mechanics, and detailed maps of planetary surfaces that would have seemed like magic to previous generations. But they'll also experience the same basic wonder of spotting Venus in the evening sky, or watching Jupiter's moons change positions from night to night. Experiences that connect them directly to thousands of years of human astronomical tradition. As our journey together through the paths of the wandering stars reaches its gentle conclusion, the planets themselves continue their eternal dance, utterly indifferent to human attention, yet somehow enriched by our observation and appreciation. Tonight, tomorrow night, and for countless nights to come, Venus will continue alternating between its morning and evening star rolls. Mars will trace its distinctive retrograde loops when Earth overtakes it in the cosmic racetrack. Jupiter will maintain its steady progress through the zodiac, and Saturn will follow its patient 29-year journey around the Sun, rings and moons in tow. The same gravitational forces that create this planetary choreography also keep our feet firmly planted on Earth's surface, hold our atmosphere in place, and maintain the stable conditions that make life possible on our world. In watching the planets dance across our sky, we're observing the same fundamental physics that makes our own existence possible, a reminder that we're not separate observers of the cosmic drama, but integral participants in the unfolding story of a universe governed by elegant mathematical laws that create beauty on every scale from quantum particles to galactic clusters. So the next time you step outside on a clear night and spot one of the wandering stars hanging among the fixed constellations, take a moment to appreciate your membership in the ancient community of sky watchers who have found meaning, beauty and wonder in these patient celestial travelers. You're participating in one of humanity's oldest and most enduring activities, connecting yourself to the deepest rhythms of the cosmos and adding your own small thread to the tapestry of human astronomical experience that stretches back to the dawn of consciousness and forward to futures we can barely imagine. The planets will continue their dance long after our own brief moment in the cosmic story has passed. But our observations, our wonder, and our growing understanding of their motions become part of the larger human story of curiosity, discovery, and the eternal quest to understand our place in the vast and beautiful universe that surrounds us. In watching the wandering stars, we discover not only the mechanics of orbital motion and the history of the solar system, but also something profound about the nature of patience, the rewards of careful observation, and the deep satisfaction that comes from connecting our individual lives to the grand patterns that govern the cosmos itself. And so, as the planets continue their eternal dance across the darkness above, may your own rest be as peaceful as Jupiter's steady glow, as gentle as Saturn's patient journey through the zodiac, and as restorative as the quiet hours when Venus rises before dawn to herald another day. Thank you for joining me on this gentle voyage through the paths of the wandering stars. Until we meet again under the cosmic dome, sleep well beneath the ancient light of worlds in motion, and dream of the beautiful choreography that connects us all to the infinite dance of the cosmos. Sweet dreams, fellow travellers among the stars, the Sleepy Astronomer.